Good afternoon, everyone. Welcome to another one of our virtual tours of outer space. My name is Josh. I'm part of the Morrison Planetarium team at the California Academy of Sciences. We are very excited to be beaming out once again from our homes to yours, doing a virtual tour of our solar system and the universe around us. So, we're doing our tour today, as we do every week, in the software OpenSpace. And OpenSpace is especially cool because it is open source astronomy and planetarium software. So if you think this show looks cool and you want to try it out for yourself, there's absolutely a place where you can do that. Go to the OpenSpaceProject.com, download it, try it out, and let us know what you think. It's a very fun software. You can use it to do basically the same show I'm doing. All we had was our engineers whip up some really special stuff for us, like those controls. And I got to give a shout out to our producer, Sharon, at our visualization studio, who created that cool intro video, as well as my behind-the-scenes producer today is Mary. So we are looking in the OpenSpace software at one of my favorite parts of the solar system. This is, of course, Golden Gate Park. Now, looking around Golden Gate Park, you can see the California Academy of Sciences. We are now reopened, which is something very exciting for us. Our members are coming to visit us until the 23rd, this Friday, when we are reopening to the general public. So if you've been missing Claude and everybody else just as much as we have, now is the time. You can reserve tickets and come check it out. Looking around the rest of the park, though, you can see the beautiful music concourse here, our sister organization, the DeYoung, off in the distance, Big Rec, that wonderful baseball fields behind the museum. I just love looking at Golden Gate Park. You can see it's beautiful, shining, bright green, but if you've been watching us week after week, you might notice the green looks a little more subdued today. What's going on? Are my monitor settings weird? Are my video output weird? No. It turns out we do our virtual tour of outer space streaming the software, which accurately records the position of stuff on planet Earth at the moment and stuff with respect to planet Earth. So what we're actually seeing is the change in seasons. And that means the nighttime line, the place where the sun is no longer shining, is creeping closer and closer to where we are in San Francisco. We are seeing San Francisco look darker because, well, at this time of year, at 4:30 Pacific time, San Francisco's darker. Our friends on the East Coast normally see this program where it's nighttime from them, but you can see where nighttime is sneaking up on us. For all of those who think that our planet is flat, well, I've got a number of arguments to make with you, but another compelling one would be that we've got these things called time zones, which really only work if you live on a sphere. But looking away from planet Earth, we can see the stars around us. We can see the illuminating light of our sun. If I tilt us that direction, you might even be able to pick out the sun itself. Always a cool thing to do. But we've got tons of really cool things for us to check out in our solar system and beyond. So if you've got an idea, something that would be compelling and awesome to check out, by all means, drop it in the comments. I love to take suggestions. We can go see your favorite object in the solar system. I see we have some suggestions coming in already. Laura, quick on the drop. They must know what's going on in this program. If you call out your suggestion early, I'm likely to see it. We are heading to Mercury. Now, the trip to Mercury is one that several spacecraft have made. Bepi Colombo is en route, I believe. But when we look at Mercury, we are seeing a surface that is, at just first glance, completely different than what we see on Earth. When we looked at Earth, we saw blues, we saw whites, we saw greens, yellows, browns. When we look at Mercury, we see gray, pretty much monolithic gray. I see slightly darker, slightly lighter gray, but it's all gray. We can see some bright white spots, which usually are areas of ejecta. Ejecta is where material from inside Mercury has been flung onto the surface because there was an impact. You can see a nice one right there, a very bright color around it compared to the kind of darker region on the sides. And this one actually has great ejecta rays right next door. You can see what I'm talking about. If I get close enough, part of this is higher contrast than the others, but check out over here. If I look at this one crater, I can see a line of light material radiating out in this direction. I can see another one over here. I can see another one over here. These bright lines are telling us about material that came out from this spot when something smashed into the surface. A nice sharp-walled crater like that. I'm guessing, perhaps more than I should be guessing as an ethical science communicator, but I'm guessing that's a more recent impact. Now, if you can see a recent impact like that, you're likely to see on that ejecta that the material from the ejecta covers up other craters. But once in a while, you might see another crater on top of its ejecta. Now, with careful analysis, I could probably tell you which one of these was older based on which one's ejecta fell in the other. That's a really cool thing. We call it superposition, or which one's on top. Generally, when you see two craters touching, the one that's on top of the other is the newer one. So let's try this out. I've got a perfect combo crater right here. Let's call this A right here and B. Which one is older, A or B? Well, with superposition, you would say that the one on top of the other one has to be older. So I would say B is older than A. But if we go from A to B to C right here, which one do you think is oldest? Which one is youngest? I'm not going to tell you. Put the comments in the chat. Again, A right here, B right here, and C, that little one right there. Which one do you think is most recent? Put the name in the chat. I would love to see what you folks come up with. So looking around Mercury, we can see this beautiful gray surface. We've got some higher color contrast images of Mercury, which are very pretty too. And looking over here, I can see another massive crater with huge ejecta lines. Every one of these cratered objects. At first glance, I get why people call them boring, but fundamentally, they just really aren't. These are beautiful, amazing, fascinating objects with a huge amount of cool things going on the surface. To call them boring is just a great miscarriage of the word boring. Okay, so backing up a little bit, let's check this out. We have another suggestion. I saw Jupiter. I love Jupiter. Great suggestion, Andrea. Let's go check out Jupiter. Now, zooming into Jupiter, this is a very long trip. It takes us maybe a few months to get something into orbit around Mercury, but part of that is making sure that you don't go so fast you dive into the sun and never return. That's not a great way to plan out a mission. Getting to Jupiter takes a lot longer. You're boosting your orbit away from the sun. That takes a lot of energy. And, well, doing that carefully in a way that gets you to Jupiter relatively quickly takes a lot of rocket fuel and a lot of careful calculation. I can see why people want to study the Jupiter, though. The surface is gorgeous. You can see those delicate swirls moving around front and back. There are jet streams carrying material around the planet. But if you want to understand the surface of Jupiter, you got to think in what we call bands and zones. Bands are dark, zones are light. Often a band next to a zone means they're traveling at different speeds or even sometimes in different directions, or at least in the micro scale, different directions. But when you look around here, you can see the most active, giant, moving bands and zones tend to be around the equator. That's not a coincidence. The equators of most not solid objects spin faster than the areas at the poles. And it's not just like a record where it's all one solid rigid object and the outer part spins faster than the inner part. That's true, but not exactly the phenomenon we're seeing here. We can actually see parts of Jupiter travel away from other parts. Like this point on the surface, if I'm watching it for long enough, this band next to it will eventually go faster than it and pull away from this part. So people say Jupiter rotates once, I think it's every 11 hours. My response to them is, what part of Jupiter? That's generally true of the bands, and I think there might be a calculation involved between all the different latitudes telling us how fast it rotates. But when you look at the poles, they are definitely moving slower than the rest. So there's a lot less action there. I see I can't fool you folks. A lot of people are throwing C in the comments. You are absolutely correct. C would be the most recent crater on Mercury. But let's see if we've got another cool suggestion. I see a couple actually popping up. Ooh. Want to see the International Space Station and Hubble Telescope. I'll tell you what, Shaima, I will do my best. Let's try this out. I'm going to bring back my controls and see if I have any of those things loaded. So around here, I can go in my menu and look for solar system, planets, Earth. No satellites loaded. So I'm sorry, I don't think I can show you any of our Earth orbiting missions. We definitely have those in OpenSpace though. In fact, I even had it loaded up on a different profile. So if you want to check them out, all you got to do is go download OpenSpace and fly there yourself. Some folks want to go see Mars. Great idea. We saw some cool colors on Jupiter. If you had to describe Jupiter's colors, I might say yellow, brown, red for that great red spot. Compared to Mercury, it is a colorful palette. Now, when you talk about the most colorful planet in the solar system, Mars is probably the only one that's known for a color. We call Mars the red planet. For sure, in the nighttime sky, you can see Mars as red, but Jupiter has way more variation. Maybe that's why we don't call Jupiter the red, yellow, orange, brown, white planet, because it just doesn't roll off the tongue. When we look at the surface of Mars, you can see a reddish surface. You can see a little bit of the Tharsis down here. You can see the great Canyon of Olympus Mons. We've talked about a whole bunch. When you talk about the color of Mars, though, again, red. Would you believe me if I told you that the color of Mars was actually about the same as the color of Mercury? That this super vivid, cool red surface was actually just a cover-up of boring old gray crater rocks, just like Mercury? Turns out it's true. Now, I'm not saying that to disparage Mars. I think Mars is great. I would never want to hurt its feelings. But it turns out that Mars is a boring gray rock planet, just like Mercury, just like Venus, and just like Earth. It turns out the inner planets are all pretty much made of boring gray rock. So why is Mars red? Why is Earth blue? Why is Venus yellow? Well, some of that has to do with the gases that surround us, at least in the case of Venus for sure. When you look at Mars, we are seeing a surface that has been changed over time. There's lots of abundant carbon dioxide hanging out in the atmosphere, I believe. And that carbon dioxide, while very thin concentration compared to Earth's atmosphere and all of our wonderful gases, is still a fair amount. We see an oxidizing process happening on the surface, which we often call rust. But rust on Earth, we generally think of as the presence of water, specifically sometimes salty water, and metal. There is iron on Mars. It is oxidizing to form this reddish color, but it's not necessarily the presence of water that's doing it. It's just change over time. Oxygen, turns out, chemistry-wise, is pretty obnoxious and just messes other stuff up. Turns out us mammals are really big fans, though. Okay, now looking around on the rocks of Mars, I should also have to add a caveat. Let's not call the rocks of Mars boring. The rocks of Mars are absolutely fascinating, as evidenced by Olympus Mons, to be sure, as well as Valles Marineris right here. Mars has cool rocks, but the color is what I was referring to, that kind of boring grayish hue. Okay, let's see. Backing up, Gustavo wants to round out our collection of terrestrial planets. Let's go visit Venus. That's alliterative. I really like that. Flying out to Venus, we get to see we don't get to see much of the surface, I should say. When we look at Venus, we see a bright object. Pretty much no matter when we see Venus from Earth, it's bright. What we're seeing is not light from Venus. What we are seeing is light from the sun bouncing off Venus. Venus is reflective. Not quite as reflective as a mirror, but let's call it reflective as a yellow-white piece of paper. It's pretty reflective. A lot of light bounces off. And it turns out that's because we have a huge layer of clouds. Like I said, the color of Venus is largely dictated by its atmosphere, because what we see of Venus is atmosphere. We really don't see a surface at all. For a long time, this led scientists here on Earth to speculate wildly about what could be happening on Venus. It was closer to the sun. It receives more energy from the sun than Earth does. And therefore, underneath these clouds, we were going to find jungles. Jungles full of all sorts of crazy creatures living on the surface of Venus. It was super exciting. And then in the 70s, some killjoy named Sagan came up with an idea of how we could actually predict what the temperature would be like. And the results did not support jungles. Instead, they said it was hot enough to melt lead. Now, that sounds pretty brutal to you and me. We don't think there are jungles on the surface of Venus anymore. Underneath those clouds, we are pretty sure there are boring gray rocks. Very hot rocks, to be sure. But this kind of makes it look like we're looking at a hot lava planet or something, and that's not really the case. This is a radar map. Since looking at Venus does nothing, our eyes don't get through the cloud layer, we used radar to bounce off the surface. Places that absorb the radar waves were bumpy, so those are colored in darker colors. Places that are very smooth bounced the radar waves off. This gives us kind of an interesting way of telling some traits of the surface. Just like Mercury, when we look at Venus, we can actually tell that this surface is relatively young. What do I mean young? Not as old as the surface of Mercury. We can tell that based on the number of craters we see on any given surface. If you see a lot of craters, it's probably been as solid rock for a very long time, so it's very old. If it's a brand new surface, it hasn't had much time to accumulate craters like Venus. It might be very young. The challenge is maybe Venus looks artificially young because of its thick atmosphere protecting the surface. Now, protecting the surface from objects, impactors, to be sure, but otherwise Venus sounds like a pretty horrible place to visit. When we talk about Venus's surface, we're talking about temperatures upwards of 900 degrees in the Fahrenheit scale, highly acidic, basically like taking a dip in a pool of acid, and pressures that are intense enough to squish you, like dropping a scuba diver a kilometer below the surface of Earth's oceans. Not at all a fun place for you or for me. Okay. Ooh, we had a request for Saturn. I love it. We are getting a grand tour of our planets. That is a super fun show. So heading away, we're going to go in the footsteps of Cassini, following out to Saturn, called the Lord of the Rings. As a Lord of the Rings fan, I wholly endorse that. It's a very silly, cool name for it. When we look at Saturn up close, those rings are, of course, the most prominent feature. When you look at them edge on, they almost disappear. It is a beautiful perspective at just how rare and special this place really is. When you look at the rings of Saturn, you can see those rings are positively delicate, vanishingly thin. When we look at the surface of Saturn, I think Laura might have noticed, we don't see the surface. We might be able to maybe use the same kind of technology, radar, to go into Saturn, bounce off a solid surface and come back. Great idea. To my knowledge, any attempts at mapping the surface like that, we send radar in and not much comes back. That's not to say Saturn's a black hole. That is not what I'm saying. I'm just saying there's not a hard, flat surface for those radar waves to bounce off of. There might be a spot deep enough within it where it becomes reflective to radio, but I don't know if we've gotten a map per se. Even if we did, it would probably yield something just round, because that inner layer is probably round. So when we talk about a gas giant like Saturn, like Jupiter, we are fundamentally talking about a different sort of planet. On Earth, we have a surface that is rocky. Above that, we have an atmosphere of clouds and air, gases. I'm a big fan of those gases, like I said. But when you look at Jupiter and Saturn, the surface is gas. Underneath that, that same gas, hydrogen, pretty much gets squished together until it becomes a liquid. We get liquid hydrogen. You may have heard of liquid hydrogen here on Earth. The way we get it to be a liquid is by making it super cold. That's one way to do it. On Saturn, they make liquid hydrogen by squishing the atoms so close together it stops acting like a gas, starts acting like a liquid. When you talk about getting those atoms even closer together, eventually it probably becomes solid hydrogen, at least in the case of Jupiter, and we get a gigantic magnetic field. Now, because this is all hydrogen all the way down, pretty much, we don't get a huge amount of change or topography on the surface. We don't think there's going to be mountains anywhere inside Saturn. It basically just gets denser and denser as you go down. You might have storms or variation, but they're temporary features that go away pretty quickly. The rings, I noticed someone's asking about Andrea, they are very visible. They're very visible. When we look at them from Earth, they are shining. If you imagine poor Galileo and early astronomers looking at the rings of Saturn from Earth, they didn't see it like we just saw it. They probably saw something like this. Now, that's just big enough, depending on how big your phone is, to be able to see that it's kind of oblong, wider than it is tall. That was all they got to see through a telescope. And once in a while, they'd look at it, and it looked like this, where it was round, and the wideness had disappeared. That was really perplexing. Now, sometimes you could see more, sometimes you could see less, but you never really got that in-depth, rich view. So originally, when people were looking at Saturn, they came up with some pretty interesting ideas about what was happening here. The first idea was that Saturn was the slowest of the known planets. It was an old man. He couldn't walk across the sky by himself, so he had one aide, an assistant on this side, one aide on this side, and they helped him walk. And when we saw the circle by itself without any wideness, it was because the aides were lined up with him. We saw one in front, one behind, but we couldn't see the aides at all. That was an okay idea, but eventually someone thought about this and got a better telescope and saw Saturn kind of like this. And they decided, it's not aides. It's one thing that goes all the way around it, like pot holders. It was wide, kind of an oval shape. But Saturn's pot holders were like ears sticking out the side. It's a pretty weird idea, but that's honestly the shape they thought Saturn was. We had several round objects in the sky and one funky shaped one. And then eventually, with more telescopes, better modeling, we began to understand Saturn as a ringed planet. And those rings look solid. They look like you could fly out to Saturn and run across them, but that's just not the case. We can see sunlight passing through them quite cleanly, casting a shadow onto the surface of Saturn itself. Hey, we got a little foreground moon there. But when we're looking at the backside of the rings, you can see again Saturn's shadow falling on the rings and making them almost invisible. That is, in fact, what we see. We get to see Saturn like with a bite taken out of its rings. The rings do not make light themselves. They are not solid. They are not glowing. What they are is a collection of teeny tiny reflective particles of ice orbiting around Saturn. And as they orbit, they bounce sunlight in all directions. But where they are not receiving sunlight, they are dark. Okay. I get real excited about Saturn. Let's go check out Pluto. Give us some variety. We spent a lot of time talking about planets. Let's talk about something that's not a planet. I'm sorry if I offended any of our viewers. When we talk about Pluto, it is a controversial object to many people who are science enthusiasts, especially on the internet, where people just love arguing. When we go visit Pluto, we get a chance to see a world that is, well, maybe actually more similar to Earth in more ways than people think. Now, how can I say that when Pluto's not even a planet? Well, when we think about Earth, one of the primary ingredients in Earth is water. There is water on Pluto. The challenge is it's not water anymore, it's dihydrogen monoxide ice. And that's actually what we're looking at here. This is a frozen icy surface. We can see nitrogen on the surface of Pluto, which is kind of a weird thing if you think about it. Humans don't normally see nitrogen. We look through nitrogen because our air is made of nitrogen. But on the surface of Pluto, this sludgy white goop that's piled in this area, that's likely a nitrogen glacier. So just nitrogen floating around on the surface. But I think the most Earth-like thing we're going to see at Pluto, not the surface nor the mountains, even though some of those are kind of Earth-like too, but the comparison of Pluto to its moon. When you look at Pluto here and its moon Sharon, we actually get to see a big moon and a relatively small planet. Now, when we compare this to Jupiter, Jupiter's got one really big planet and some pretty big moons, but the planet is so big that the moons are dwarfed. They're tiny and insignificant in comparison. When you compare Mars to its moons, Phobos and Deimos, they are vanishingly small, barely asteroids. It's hard for me to even call them moons. When you look at Pluto and Charon, they're pretty close in size. Pluto's about 4 times as tall as Charon, so I think it's close to 3 times as tall as Charon, so it's close to 9 times the volume. It's a pretty close comparison, though. These are very large objects, very small objects, very similar to each other in size. It's a relatively large moon and a very small planet. The closest comparison for moon to planet size in our solar system is Earth and our moon. When you compare those two, we get kind of a similar ratio to Pluto and Charon. That's really cool. So our moon, almost by necessity, must have formed around planet Earth. Likewise, Charon must have formed around Pluto. And I want to show you one last really cool thing. If I go to our orbits, I can show you our planet trails. Check this out. This is supposed to show us how Pluto goes through the solar system, but it looks like we stuck Pluto on a pin. Like it went straight through. That's not a mistake. It's not my computer choking on OpenSpace. What you are seeing is an entirely basically accurate decision. What we're seeing is where the center of the Pluto-Charon system is. Pluto doesn't orbit Charon. Charon doesn't orbit Pluto. They go around each other. They are co-orbiting. And that point right at the end of our green stick is the point they are traveling around. So Pluto makes a small circle. Charon makes a big circle, but they are orbiting one another. We had a request from Laura to zoom in on Charon. I will do my best. Now, Pluto's got some super cool names on its surface. It's got names of monsters of the underworld. And if you look up the IAU suggested names, I think some of them have been accepted too. Pluto's features are like Cthulhu plane and basically big dark monsters. When you look at Charon, oh my gosh, it is so cool. It is named for I messed that up. Pluto's got explorer names on the surface. Sharon has the spooky monster names, but it also has science fiction and fantasy names. So they had like Skywalker features, Solo features. This is the Mordor plane up here. It is so cool. I said I was a fan of Lord of the Rings. It is wonderful to be able to see Lord of the Rings mythology writ large across our solar system. Sharon's got some amazing stuff. We have very limited photos of Sharon. It was kind of a sideline to the New Horizons mission that took those great photos of Pluto. But what we learned was exciting and awesome and challenges our perceptions all the same. Okay, we got about 5 minutes left. I think that's time for at least one more object. Uranus. Great suggestion from Blanca. Okay, let me dial in Uranus. Now, if we were talking about colors for planets, you can see kind of our cheat sheet up here. The orbit lines we've colored to help us remember which planets are where. We are heading into the second to last major orbit, and this has this light blue color. Why would we decide a light blue color for Uranus? Well, check this out. When we look at Uranus, you can see a little bit of sunlight glinting off that atmosphere. It's an ice giant, so not a gas giant like Saturn and Jupiter. But that light blue color is actually a surprisingly accurate match for the robin's egg blue that is the surface of Uranus. Now, as Uranus goes around the sun, you might notice something kind of funky. Right now, it looks like a featureless blue ball. You can see one half of the featureless blue ball is lit up from the sun. The line of its orbit gives us a sense of perspective on how it moves through the solar system and how it's lined up. So I'm going to ask you, where is the North Pole of Uranus? You might think, based on all of this, it's right here. Right? Right up there? Alas, this is a funky planet. The North Pole is right here. This yellowy area is a good indicator of where the North Pole is. And as we spin around, you can see that North Pole is pointed almost exactly in the direction of the sun. That is what astronomers like to call super wacky. So, talking about Uranus, this is a planet that has features that we don't really see on any other planet. Pluto is heavily tilted, but not exactly tilted over on its side like Uranus. We can also see similar stuff on, well, Earth has a polar tilt. That's what gives us our wonderful seasons. And actually, technically, is causing that effect we saw at the beginning of the show, where San Francisco is slightly darker than expected. Now, I see a couple folks throwing in a comment about something that is happening right now, our Orionids, the meteor shower that is happening this evening. I've had a couple friends ask, what do I do? How can I see it? The best suggestions I can offer you, the same ones I gave them, are you need to remember 3 important things for your meteor shower voyage. Number 1, a chair. It's nice to be able to sit for a long period of time. Number 2, a blanket. Number 3, the heated beverage of your choice. If you can go out and find a nice dark patch of sky, preferably away from city lights, put yourself out there and sit for as long as you can. Stay warm for as long as you can and spot as many meteors as you can. They're saying between 10 and 20 an hour would be a great turnout for this. And you're going to want to look in the direction of Orion, but not necessarily at Orion. So it's not very important about where you're looking in the sky. Just keep looking towards the east. Now, we should see the best part of our meteor shower at a special time of night. That's really between midnight and 3 in the morning. Now, that's an unpopular thing to say. People want me to say, oh, the best time of night is 8 o'clock. That's not true. Now, that has everything to do with the view we are looking at this moment. When we are looking at how Earth travels through our solar system, you can really think about what a meteor shower is. A meteor shower is where we have a bunch of stuff left behind by a comet as it traveled through our solar system. And right now, we are traveling through the part of our solar system where a comet left behind a bunch of stuff. So imagine this whole area of our solar system is just full of little bits of debris. Now, as Earth is traveling into it, the part that's going to be struck by the most bits is going to be this leading edge, the part that's facing into where we are traveling through space. On this part of the leading edge, it's daylight, and it's really hard to see meteors in daylight. On this part of the leading edge, kind of between midnight and when the sun rises, that's when you'll be seeing meteors. So as you get closer and closer to where the sun's about to come up, that's where you want to be on this part of our planet. You don't have to fly anywhere. Our Earth is spinning. And as you get to the part of our planet that's on the leading edge and still dark, that's when you're going to see the most meteors. So really cool opportunity to see our Orionids, and for pretty much any meteor shower that goes. What you want to do is wait till late night / early morning, sit down with a nice comfy lawn chair, a blanket, and I prefer hot chocolate. So with that, we are back here to our very own planet Earth. It is 5 o'clock on the nose. Thank you all for tuning in, for the great suggestions. I had a lot of fun today. As I said at the beginning of the show, the Academy is reopening, and we cannot wait to see you. So the moment you get an opportunity, come check it out. Seeing audiences again, I know, has made my life very enjoyable. And I think for a lot of my staff too. Getting a chance to interact with folks is why we do this job, why we love connecting with our crowd so much. So thank you all for joining us. Thank you for staying tuned throughout our shelter in place. We will continue doing our weekly broadcasts until the planetarium reopens. So stay tuned for more news about that. We're still trying to figure out that date. But for myself, Morrison Planetarium, the OpenSpace software community, the American Museum of Natural History, and all of our collaborators across the world, thank you for joining us. Have a great rest of your day.